Testing. This is page 5 of chi-squared, specifically chi-squared goodness of fit. And we're coming back to chi-squared after some time off because now we know how to do binomial distribution, we know how to do normal distribution, and using this new knowledge, we can use chi-squared goodness of fit to compare our distributions to distributions that are not uniform. Remember, uniform distribution is evenly distributed. We're going to have distributions where there's a lump in the middle, which is something that is happens a lot in real life. So it's more useful if we can do that comparison. Okay, so let's look at exercise 8E number 1 here and see how to do these problems. Number 1, Marius works in a fish shop. 1 week he measures 250 fish before selling them. His results are shown in the table below. You can see that there's a bunch of stuff, a bunch of intervals on the left. These intervals, these categories don't need to be numerical categories, but in the case of comparing with binomial distribution and normal distribution, they usually are intervals or specific numbers. And on the right side, we have the frequencies. So the frequencies are the ones we're going to put into L1 later. Remember, in chi-squared UF, you use L1 and L2. L1 is going to be your actual frequency observed, which is this first table here. And then the second L2 is going to be your expected frequency. So let's look at the second paragraph. Marius is told that the lengths of the fish should be normally distributed with a mean of 19 centimeters and a standard deviation of 3 centimeters. So, and then it shows a table of the distribution you would expect to see if it is normally distributed. And let's use what we know about normal distribution to calculate some of these unknown numbers here, which they didn't give us, okay? So first of all, how many fish are there? There's 250 fish. So basically, all the numbers in the expected frequency column add up to 250, just like these add up to 250. Now, what about this column that says probability? Those just add up to 100% because the probability of something happening is about 100%. I say about 100% because what about the fish that are below 9 centimeters and above 30 centimeters? We didn't count those. We didn't count them because they're like very rare, okay? So basically, even if we don't count them, we're going to basically account for all the fish. So what we're going to do is we're going to do second norm CDF, second distribution norm CDF to find what numbers go into these three cells here, 15 to 18, 18 to 21, and 21 to 24. So let's do that first. We'll do second distribution, and then we'll go to the norm CDF because norm CDF is what we use to change intervals into probabilities. So our interval is going to be 15 to 18, right? 15 to 18. And then we need our mu and sigma, which are our mean and standard deviation. The mean is 19. The standard deviation is 3. So we just put 19 and 3 in for mu and standard deviation, and then we do paste to see what would be this probability. It's 0.27823. So I'm going to put that here, 0.27823. I put extra 3 as significant figures because for expected frequencies, sometimes it's good to have more. 18 to 21. Let's repeat that with 18 to 21. Second distribution. So, you know, the reason why these problems take longer is just because there's a lot of, you know, you do a whole bunch of norm CDFs. Okay, come on. Second distribution, norm CDF, not PDF. And now I'm going to put the interval 18 to 21 because that's the next one. And I keep mu and standard deviation the same. And it's going to be 0.378. 0.07. Okay, now I'm going to do from 21 to 24. So second distribution, norm CDF, 21 to 24. Change my calculator. So now I need to put in the mu and sigma again, which is 19 and 3. And the answer is 0.20470. 0.20470. Now what I'm going to do is I'm going to multiply these percentages times the total number of fish, which is 250, and that's going to give me my expected frequency. So I'm going to do the last ones first since it's still there, times 250. Oops. 250. So the last one's going to be 51.18. And let's see, the other ones that I did were, let's see, I did 0.278, 0.27823 times 250. 69.558 and 0.37807 times 250, and that would be 94.52. 9.52. Okay. Okay, so now that we finished the expected frequencies, it says part E, two of the expected frequencies are less than 5, which is the one here, that's 2.35, and 0.927 down here. This is something you have to deal with in your IAs. It's not really something you deal with on the exam because they're not going to give you problems in chi-squared where the expected frequency is less than 5. But when it is less than 5, that is a problem. You should not apply chi-squared if the expected frequency is less than 5. So how do you resolve it? The way you resolve it is you just group together the adjacent category. So I'm just going to put 2.35 together with 20.35. I'm going to group 9 through 12 together with 12 through 15. I'm going to make a new category, which is going to be 9 through 15. And then I'm going to do the same thing with these last two categories. I'm just going to make a category that's 24 to 30. And now instead of having 7 categories, I'm just going to have 5. So if I group these two and I group these two, the expected frequencies, instead of 20.35 and 2.35, I add those together, so I get 22.7. And then for 10.99 and 0.927, when I add those two together, I get 11.917. So now I have two categories, which are 9 through 15, instead of 9 to 12 and 12 to 15, and then I have 24 to 30, right? If I add the observed frequencies together, I get 5 plus 22 is 27, and 10 plus 2 is 12. Why did I do all this work? Well, now my expected frequencies are all above 5, which is my objective. Then I can use chi-squared test, and I don't have any statistical problems. Okay, so that was part E. And remember, you're only going to do this on the IA. It's not something you're going to do on the exam. And then I have rewritten the original table, okay, and the table of expected frequencies. Now I'm going to write down the number of degrees of freedom in this new matrix, or this new row of data. I have 1, 2, 3, 4, 5 expected frequencies instead of 7. So now my degrees of freedom is going to be 5 minus 1 equals 4. By the way, I just noticed that the way I copied and pasted this problem, I should have gone up to this top right part here. So let's go up there and see what it says. Okay, his results turn on the table. And then so standard deviation. So he decides to perform a chi-square goodness of fit test, its 5% significance level, to find out whether the fish he measured could have come from a population with this distribution. Okay. Part A, write down his null and alternative hypothesis. So his null hypothesis would be blah, blah, blah is distributed, and normally say uniformly, right? All the problems up until now we said distributed uniformly, but now we have other options. For example, in this case, it's normally distributed. So the null hypothesis would be blah, 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 which in this case is length of fish is normally distributed. That would be the null hypothesis. And the alternative hypothesis would be length of fish is not normally distributed. Okay, so that would be the answer to A. What about B? Find the probability that a fish is between 9 and 12 centimeters. And so we already showed how we do that. We do that with norm CDF. They were actually talking about this interval here, so the probability would come out to be 0.081396 if you would do that with normal distribution, right? Part C, in total, 250 fish were measured. Calculate how many fish you would expect to be between 9 and 12. So then you would multiply 0.081396 times 250, and that would give you 20.35. Okay, they already have these done. D, complete the table of expected values for 250 normally distributed fish with a mean of blah, blah, blah. So that's what we did here, right? We did that for these three. And then part E says, okay, there's some expected frequencies which are below 5. We took care of that already. We talked about how to solve that by grouping these two intervals together. And then it says rewrite the original table. We did that. And now we're going to do part G, which is write down the number. Oh, we already did that. We did 5 minus 1 equals 4. Now we're going to do part H, which is find the chi-squared value and the p-value. So let's turn the calculator back on. Okay, and so what I'm going to do first is I'm going to type in this data here. So 27, 71, 88, 52, and 12. I'm going to put that into L1. So 27, 71, 88, 52, and 12. I put that in L1. Then in L2, I'm going to put 22.7. And then 69.56 and 94.52, 51.18, 11.917. That's what I'm going to put into L2. Okay. And then I'm going to do stat, test, chi-squared GOF, which is on the second page. So I'm going to go up instead of down. A little bit closer. Select D. L1 and L2, I don't need to change those because that's exactly where I put them. The degrees of freedom is 5 minus 1 equals 4. So I'm going to change the 5 to a 4. And then I'll go down to calculate. And it tells me a chi-squared value. It tells me a p-value. So the chi-squared value is, chi-squared is 1.31. And the p-value is 0.860. And then so let's take a look at how to interpret those. Part I, okay, the critical value is 9.488. So in this case, our chi-squared value is less than the critical value. So what that means is that we accept the null hypothesis, right? So it is normally distributed. And then it says write down your conclusion for this test. So we could say, okay, we accept the null hypothesis. We could also do this with the p-value. The p-value is 0.860, right? And the 0.860 is greater than the significance level. Remember the significance level, they said, I think it was 5%. Yeah, 5% significance level. So we compare 0.860 with 0.05, and since it is greater, we also accept the null hypothesis. So you could either use the p-value or you could use the chi-squared value. That is the end of this problem. The only thing different about it from before is we have normally distributed data instead of uniformly distributed data. And we also took a look at what you do when the expected frequencies are less than 5. You merge categories together. And that's it.